Welcome to the BA webinar marathon. We're excited you could join us today for Mark Wilcock's session, Tools for Exploratory Data Analysis using Excel, R, and Azure Machine Learning. My name is Thomas LeBlanc. I'm the moderator, and I have a few quick introductory slides before I hand over the reins to Mark. Next. If you require technical assistance, please type your question into the question pane located on the right side of your screen and someone will assist you. This question pane is also where you may ask any questions throughout the presentation. Feel free to enter the questions at any time, and once we get to the Q&A portion of the session, I'll read your questions aloud to the speaker. You're able to zoom in on the presentation content by using the Zoom button located on the top of the presentation window. Note that there will be some short evaluation at the end of the session, and your feedback is important to us. So please take a moment to complete it. It will appear in your web browser. Next. If you like what you hear in these webinars, make sure to attend the PASS Business Analytics Conference taking place May 2nd through 4th in San Jose, California. With hands-on learning opportunities from data and business analytics experts and a variety of networking opportunities, the PASS Business Analytics Conference is a great opportunity to gain valuable skills and advance your career. All webinar registrants get $100 off the 2-day pass. Just use discount code BA Marathon, no space, during registration. Visit passbaconference.com to register today as the discount code expires January 1st. If you're interested in accessing other free educational content, the PASS organization has a variety of virtual chapters which offer free webinars to their members every month. Check out upcoming webinars and past recordings of webinars from our Business Analytics, Excel BI, Business Intelligence, Big Data, and Cloud virtual chapters by visiting www.sequelpass.org/VC. This BA Marathon session is presented by Mark Wilcock. He's an independent consultant in analysis, reporting, and visualization for the finance, risk, and treasury industry. And he's also a member of the London BA user group. And without further ado, here's Mark talking about tools for exploratory data analysis using Excel, R, and Azure Machine Learning.
Thank you, Thomas. This talk is going to be a very practical talk. Most of the time I'll be showing demos of Excel, R, and Azure Machine Learning. But first I want to talk about why exploratory data analysis, or EDA, is really important, and then I want to spend a bit of time introducing the data set that we'll be using to compare these three tools. I work in business analytics for investment banks, basically looking at building systems to measure the market risk and credit risk. And in my day-to-day job, I get lots and lots of data thrown at me. We get data from all the trades and the trading activity, the trades, the traders, the products, the amounts, the currencies, everything about the trades themselves, and there can be millions of those. We get a lot of detail about all the market prices of FX rates and equity rates in the market. And we also have all the history of that, because to work out what the rates might do in the future, we need to know a bit about the history. Lots of reference data about our counterparties, our issuers, our bonds. And that data is a lot of different data sources, a great difference in variety, a difference in type and frequency. And the one thing is constant, that data is always never perfect. In fact, it's sometimes really bad. And it's really important that when you get a new data set and you look at it, you explore the data set, you try and understand the data set. And that sets the project and the analysis and the kind of subsequent reporting that you do on the right track, because you understand it. Otherwise, you can go off on the wrong track. because the data is never as advertised, it's never as the people who have the source system who give you the data say that it is. So to the agenda, first of all, I want to define exploratory data analysis. In brief, that is basically looking at a data set, eyeballing it, doing some statistics on it, and doing some plots. That's a very dry and dull definition, and I don't think that captures kind of some of the excitement and some of the thrill of doing data analysis, especially with these tools. So I like to consider when doing data analysis a bit like a detective on the trail, trying to interrogate the data to give me clues about so I can get meaning and insight into the data. And data analysis is sometimes frustrating. I say the data is poor quality, it's very complicated, it never matches, but I think it's become less frustrating and even enjoyable with these free tools that I'm going to talk about. Now, 30 years ago, 1986, John Tukey, who's a famous statistician, said that exploratory data analysis is three things: attitude, flexibility, and graph paper. Well, I think the reason that we're all here is that we have got the attitude, the curiosity about data analysis, and the flexibility. But have we got a better graph paper 30 years later on? Well, let's see. I'm going to give 3 candidates for that better graph paper. Excel, and we're not so much looking at Excel as a couple of add-ins to Excel. Power Query, which allows us to source data from all sorts of varieties of sources and to prepare it for analysis and to manipulate it. And Power View, which allows us to visualize it, and I'll be showing those. Excel is our yardstick. It's on all of our desks. We know it, we love it most of the time, and therefore anything else, any of the packages have to be either very different, have to have some other additional benefits or that for us to consider using them. And I'm going to talk about R, the open source language, the stats language, and especially we're going to look at a couple of packages in R. R is an open source language, and one of the jewels in R's crown is that so many of the open source community build lovely packages to extend it. And we're going to have a look in particular about using R with a couple of packages, ggplot2, which does fantastic graphics in a very small amount of R code, and dplyr, which does very neat manipulations of the data. Finally, we're going to look at Azure machine learning, and that's Microsoft cloud-based and a very different style of doing things to both Excel and R. So we're going to take this data set and we're going to do the same analysis on it with these 3 tools. And that sounds maybe a bit boring, but what I think that the tools are so different that we do it in 3 very different ways, and I think it's very interesting to show the difference. All these tools are free or cheap. Excel you have already. Power Query and Power View are free add-ins to Excel, and in fact Excel 2013 they come built in Excel 2016. R is open source and free, and Azure machine learning, the monthly fees start very small, and actually to build the machine learning experiments where we'll do an analysis is actually free. Well, I'm going to be showing quite a lot of code and examples, and all that will be available on the website at the bottom right, zomlex.co.uk, by the end of the day. I'll put it out there. So let's get started. And to introduce the data set, I want you to imagine that the next BA conference, Business Scientists Conference, is not going to be in California, too much sunshine there, but instead what we're going to do is we're all going to go on a cruise. SQL cruises have been done before, and I'm going to be the organizer of the cruise. And obviously I need information from you, some details, your name, your age, and a few things like that. But there's also 3 other details that I need from you, and I want you to think about this. First of all, do you want to go first, second, or third class? And by the way, you're paying for yourself on this, so that's up to you. Secondly, I want to know about your nearest and dearest, who you're going to take on this cruise with you. Now, I don't need names. What I need to do is to boil that down to 2 numbers. The first number is the number of siblings and spouses. So if you're taking your wife or husband and brother and sister, that would be 3 siblings and spouses. And The next number is your part, your parents and children. So if you're taking your 2 parents and a couple of children, that would be 4. The queue, I want to know where you want to get on. The cruise is going to start off in Southampton in the UK. That's on the south coast of the UK. We're going to cross the channel and go over to Cherbourg in France. And then we're going to stop over on the west coast of Ireland in Queenstown. And then we're going to cruise across the Atlantic and arrive in New York about a week later. So a few of you will have realized already the slight flaw in my cruise planning, which is that this ship on the right, this very beautiful ship, has already sailed. In fact, it sailed about 104 years ago. It's of course the Titanic, and I'm sure that everybody knows the story of the tragedy of the Titanic. 4 days into the Atlantic, it hit an iceberg and it sank. There were 2,200 people on board. Only 700 survived. They went in as lifeboats because everybody thought that the Titanic was unsinkable. So that's in a roundabout way of introducing a data set. And what I'm showing here is the first 4 rows of that data set. And let's talk about the data set. And what we maybe want to try and analyze is which passengers survived and which died, and if we can work out what factors might have influenced that. Now, I've got a data set of not all the passengers. There were 2,200 passengers. I've got a data set of about 980 odd passengers. And here are the first 4. And just let me explain this to you. Our first passenger is Mr. Braund. He is Owen Harris to his friends. He is a 22-year-old man. He's traveling 3rd class. He's traveling with 1 Civ SP, so a wife or a brother or sister, and no children, no parents. We know his number. We know he paid £7 and 5 shillings in old money. This was before decimalisation. We don't know his cabin number, but we know he embarked at S. S is for Southampton in the UK. And the fact that we've got a 0 there on survived means that he actually died. Let's compare him to Mrs. Cummings, Florence to her friends, wife of Mr. John Bradley Cummings. And that even the name tells us a lot about the kind of social conventions of the age that women were called after their husbands. So she's a 38-year-old woman. She's traveling again with 1 CSP, maybe Mr. Bradley himself. We do know her ticket number. She's actually traveling 1st class. Her peak class is 1. And she paid 10 times as much as Mr. Braund. We know her cabin, and we know that she embarked in France in Cherbourg, and she actually survived. So now I want you to look at the data, and as I said, when we get data like this, it's never as we want it to be. And you might want to look at the data and think, you know, what would you do? What would you ask from the provider of that data to give you? Well, for me, there's a few things. First of all, if I'm looking at it, I think things like survive being 0, well, that's not very intuitive. So for my analysis, I'd like to change, instead of 0 and 1, I'd like to have died and survived. Secondly, if I look at passenger class, again, we've got numbers that are 1, 2, and 3. 2 is not twice as good as 1. So maybe I'd like to make that instead a category 1st, 2nd, and 3rd. What you can't see from this data, because I've only shown you 4 rows, is that there are actually some missing values in the total data set. So for example, there's about 200 missing values of age there. Now it's interesting why there's ages missing values. You think they'd collect that information, but there are those missing values. So we have to think about what to do about those. I don't particularly like the way that they've put CSP and parts together. For me, I'm interested in when somebody's traveling, what's the total family size? And that would be my siblings, my spouses, my parents, and my children, myself. So I might want to have a variable that, for analysis, that's family size. And so we'll calculate that. Right, so there's lots of data. I might also want to have a look at the name. I don't like the name being just in one field. From a relational database background, I'd like to split that field into maybe a title, a surname, and some first names. So there's lots of things that I'd like to do, and we're going to go in and we're going to improve that data. First of all, we're going to improve it in Excel, and then we're going to analyze that data. So without further ado, I'm going to go to my Excel. Lovely. Okay, so we're going to bring that data in. That data is in a flat file, so I'm going to go into my Power Query. I'm going to go from File. I'm going to import from CSV, and here's my data. And I just click OK. And Power Query is going to import that for me. Lovely, and it's done that. Now, so here we've got the data. Let me just show you the first row. Here we can see in the first row Mr. Braun. It's exactly the same data that I just showed you in the previous slide. Here he is, Mr. Braun, 22-year-old man, and that's data, and then Mrs. Cummings below him. And so we brought that data in. Now, what's nice about Power Query is that as it's applied to steps, it can show you the things that it's done. So if I click on a particular step, it shows you the state of the data just before applying that step. And the nice thing I've just pointed to it is it's already done 3 things for us. If I go to change type, it's basically worked out that it's got some column headers. So it's made the first rows column headers, it's made them column headers, and it's also worked out that certain rows, it's worked out the data type of each row. So if I look at part, we can see it's a whole number, whereas if I look at name, it knows it's a text field. So what I want to do is I want to apply all those improvements to data that we talked about when we saw the slide. And so I'll do the first one, and I'll go and I'll add a column, and I'll say that what I want to do is going to add a custom column that comes up. I'm going to create a column called survival. And I'm going to say that that survival is basically, the formula for that is if my survive column equals 0, then I'm going to say died. Otherwise, else, survived. We can see there's we got a problem there. What's that? Else divided, else survived. Token ERF expended. I can't quite see what the problem is and equals. If so, stays it. So let me just try that again. If not, I've got one that we before the show. I wanted to show you to do that. Let me just cancel that, because what I can do is I'll go and say I'll go file, and I'll just go and I'll just discard that, because there's one that I built just beforehand, and I don't know why that formula didn't work. Curse of the demos, but here we go, and I'm going to go to my show page. Here's one I did before, and it's let's edit that, and let's have a quick look at that. And there's my survival column, and there, I don't know what I did to get that wrong. It just looks the same formula. So what I've done is I've added the survival column. There we go, and we can see I died and survived. Once I've added the survival column, I can remove the survive column, and then I can do lots of other things. As I say, I prefer, instead of S, C, and Q, I'd like Southampton, Cherbourg, and Queenstown, because they mean something to me. What I like to do, they gave us the fare as a number in pounds and pence, but maybe from my analysis, I'd like to split it up into 4 bands: below £10, 10 to 20, 20 to 30, and above 30. And with this particular one, I can do that. So I can click, I can build these formulas. Let's have a look. Let's go to there. There's my fare band. I mentioned that the age was, I'm creating one called estimated age, which is here. And what I'm simply saying is, if the age is missing, then I'm going to make it the mean age. I happen to know from previous analysis the mean age is about 30, so I put that in. And then I've said that I didn't like the passenger class being 1, 2, and 3. So what I'm going to do is I'm going to change my passenger class, first of all, to a text, and then I'm going to replace 1, 2, and 3 with first, second, and third. And then lastly, what I'm going to do, I'm going to do another my last thing that I'm going to do is I'm going to finally add a column. Wait for that to come up. We're going to add a custom column, and hopefully it will work this time. And I'm going to say, we talked about the family size, so I'm going to say my family size equals, and I said it's going to be equal to my SIB-SP plus my part plus me. Unfortunately, that one is saying it's fine, so I'm going to say OK. And then I've created my family size and family size 0.1. So I've obviously done it before in the demo. So I've created my family size. In fact, let me just get rid of that one. Lovely. So now I've made the changes to my data. I've made these improvements to my data with Power Query. I can go in and I can close and load it. And lovely. Lovely. And I've loaded it to this particular Excel table here. Let's just get rid of that. And here's the data, and you can see I've got things like my various columns, my survival column, my estimated age column, and so on. Now I've got the data, now I can start maybe analyzing it. And the first thing that I'm going to do is do what the very classic thing, which is to create a pivot table on top. And so let's have a look at this pivot table. This pivot table is looking at the count of passengers. As I say, I had 891 passengers, and we're looking on the rows by gender, men and women, and then we're looking by passenger class, and we're doing an analysis on the columns of who died and who survived. And now straight away we can start making our first conclusions. We can look, and for example, we can say even the most basic thing, we can say that of the 900 people on board, there are roughly 300 women and 600 men, roughly twice as many men as women. But then if we maybe have a look at those that survived, we can see that of the women, many more women survived than died, whereas the men is exactly the opposite. The 468 men died and only 109 survived. And then if we have a look maybe more in the more details about by passenger class, we can see that women traveling first class were very, very likely to survive, maybe about 97%, whereas those traveling second class are also very likely to survive, just a bit worse. Those third class are basically evens chance. For us men, the odds are distinctly darker. Even in first class, there's a kind of 2-to-1 odds against survival. In second class, it gets to about 5-to-1, and by the time we're in third class, it's 8-to-1 against. So already we've drawn some conclusions. We put a pivot table and we've drawn some conclusions. But it is very difficult to get insight out of a text table, and visualizations help a lot better than that. So I'm just going to show a couple of small visualizations, and I'm going to explain why I think they're useful. This is again a visualization of survival, and it looks quite boring at first. What we've got is 3 column charts and 1 bar chart. So we've got our count by gender, by where they embarked, and by passenger class, and we've got who died and survived. But what's nice about it, first of all, we can obviously say, obviously we can see that more people died than survived. We can see the relative numbers of people that have gotten in the various embarkation points. We can also see a little data quality issue here. We've got 2 people and we don't know where they embarked at all. So that brings it out. So that's quite nice. But what we can also do, let me just unclick that, is we can click on a particular category, and in all the other graphs they're linked so that category shows up as a darker blue and a lighter blue. So here we are clicking on the women category, and we can see that if we look at here, that basically we can see that a lot more survived than died, whereas if we have a look at the men, we can see that by looking at that, of all the people that died, the great majority were men. We can do another analysis saying, what happened in third class and what's the relationship? Well, we can see maybe that nearly everybody that got in at Queenstown was going third class. Whereas if we look at Cherbourg, we might see something different. Yeah, maybe people first class there. So it brings out, we can tease out and see quite a lot of the relationships between the different factors, between the different variables that can give us some insight into that. So a very simple chart, but with this kind of linking approach, it allows us to investigate and gain lots of insight from it. I want to show another chart which is also quite interesting. Here what we've done, if I open the filter, is we've filtered on women only. And what the chart shows is it shows on the rows, we remember how we split things into fair bands, the fair bands. We show below 10, 10 to 20, 20 to 30, and at the bottom above 30. And then on the columns, we've got a first class, second class, and third class column. And what's quite interesting, the red is survived, the blue is died, is as we've seen before, if we look at first class, exactly as we expected, most of the women that survived, and obviously most of the people in first class were paying above 30 quid. We can see that a few people pay slightly less than that. In second class, it's the same thing, though it's quite interesting. You can go second class for just above £10. Whereas for third class, something very interesting is happening here, because we can see that if we paid above £30 and went in third class, then we were most likely to die. Whereas if we paid £10 or less for the cheaper fare, we're much more likely to survive. And that goes against what we've seen before. So that raises some interesting questions. I don't know the answers to that. Maybe it's something of the way that the cabins were laid out on the boat. I don't know. But again, using this visualization and these interesting questions jump out at you, and they can form interesting conversations with the clients about why things are the way they are. So what I've hoped to show there is how the kind of visualization, even simpler visualizations like this, can give us a lot of good information. So back to the PowerPoint. So what we've done is we've shown our Excel demo. Okay, and now what I want to do is I want to do the same thing, but I want to do it with R, and let's get started with that. So. Right, so here I am. I'm in RStudio, which is a development environment for R, and we've got various panes there. In the top left pane is about 200 lines of R code. But don't worry, I'm not going to show it all of you. I'm just going to pick out a few interesting bits. And in the top left, that was in the bottom left, that's our console where our code will be executed and results in error messages shown. Any objects that we create, any data frames, which is R's equivalent of tables, will show in this top right pane here. And in the bottom right, we're going to see any plots that we produce. So let's get started with R. And the first thing that we've got to do, I mentioned that R has got lots of, let me just bring this down a bit. R has got lots of libraries, and we're going to bring those in, and in particular we're interested in this library, that ggplot2, which will do our graphics for us, and dplyr, that'll do very succinct data manipulations. So the first thing that we do is we're going to get the data into R. We're going to load the data into R, and you can see that it's a very simple command. We're just using this read.csv, and we put our data into a data frame, a table called df. And it's appeared here in the top right. If I double click on that, we will see the data. Lovely. So again, this data is starting to look very familiar to you. We can see here's Mr. Harris, here's Mrs. Cummings, and it's exactly the same data because it's exactly the same file that I've loaded as we saw in Excel. Let me just kill that. And so let's go back and go a bit further. Let me just do that. And okay. So first of all, what we can do is we can look at the structure of our data. That's why I need to do that there. So let me just lift that up. So I've said give us the structure of our data frame, and that's just telling us other the various columns in our data frame. It's showing us the first few rows. A passenger ID obviously is a surrogate key. It shows us, ticket. It tells us if it's a number or a text. Text it changes into factors, into categories, and so that gives us some good information about our data with just one keystroke. More interesting might be if we have a look at our summary of our data, and that does a kind of 5-point summary on each of these. Let me just go up a bit. So here we are, we've done a summary, and if we have a look at, for example, in the summary, if we have a look at the age, this tells us here we have the youngest person was 0.42 years, 5 months or something. The oldest person was 80 years old, and the mean and the median were just about 28, 29, quite a young group of people. And it also tells us that there are 177 missing values. If we want to have a look at a particular category, for instance, here's our embark category, we can see that most people got on at Southampton, then Sherbrooke, then Queenstown, and we also see that there's 2 people there where we don't know where they got on. It was a blank value. Okay, so let's go back to our code. We've done analysis. Let's have a quick look at a couple of things. We can do a quick table that tells us just a quick count. 549 died, 342 survived. We can change that as percentages. 62% died. And we're going to do our first plot here. And here we go. And here's our first plot. I'll zoom in. And what I want to do is, here is our first plot. What it simply shows is on the left-hand side, 0 who died, 1 who survived, and it's simple counts of the number of passengers that died and survived. Now, this is not the best plot you've ever seen in your life. It might won't win any prizes for analytics. It might win some modern art prizes, kind of light grey, dark grey, blobs on a light grey background. But the thing here is to just show how easily we did that plot and how succinctly. So here we've got our call to ggplot. What we're saying is we're using survived is on our x-axis, and since survived is a 0 or 1, what we're saying it's a factor. We're saying treat that as a category, and this says simply draw it as a bar chart. So with a very simple, a few simple commands, we can do that. Now we've done that, what we're going to do is we're going to do the same sort of improvements to the data, enhancing the data, feature engineering than we did with Excel. And as I was saying, in Excel, what I tried to do was to show you how to do this survival. And I'm saying survival is either survived or died. Let's just run that. So what we're doing is we're saying, okay, we're going to change the data frame. We're going to create a new column called survival. And this is the formula that we're going to use. And then again, if we look at our data frame, and we can see that now we've got this survival column here, and it's been added to the data frame. And then, so let's go on. As we've done this is more the same. This is setting our passenger class as categories first, second, and third. And this is, remember how we did at the last, we calculated the family size as the sum of CSP's part plus 1. This is just exactly the same way we're seeing that again. And then we can do some other things. I won't go over them, but we're basically kind of working out if somebody's an adult or a child and then calculating these fur bands. And I've done those. Again, if I just go to the data frame, I can show you that we've calculated there's our adult and child and there's our fur band. So we've enhanced our data, and we've done it in a very different way to Excel and Power Query. Now it's time to do some plots and do some analysis. And maybe the first plot, since we decided on doing this family size, let's have a look at a bar chart. Again, a family size, again, we're just doing a ggplot. X-axis is family size and the bar chart as we've seen before. Let me zoom in and show it to you. And we can see that most people are traveling alone, and but there are 1 or 2 families. In fact, there's a family of 11 people there. And what we might want to do is say, okay, if we have that family of 11 people, let's have a more detail, let's have a little digression and have a look at it. So here we are, we're creating a new data set called large family, and we're going to filter, we're going to just select those rows where the family size is 11. And we've done that, and we can have a look at this large family if I bring it up. and we can see it's a family of the Sage family. And unfortunately, this family all died. Maybe one of the reasons for that, you can see survivors 0 all of there. Maybe one of the reasons for that is that maybe they were waiting. A large family dispersed all over the boat when the iceberg hit. Maybe they didn't want to get in the iceberg into the lifeboats until everybody was together, and then maybe, as I said, there weren't enough lifeboats to go around, so maybe it became too late. Anyway, that's just theory from the data. Let's go back to our code, and let's have a look at a few more plots. And so here we're going to do a slightly more interesting plot, and simply what we're doing here is we're just doing a plot where we're showing survival by color, we're showing analysis, survival by gender, men and women. We can see that most men, as before, most men died, most women survived. Let's make that a bit more sophisticated, and let's have a look at this one. And the difference to this one is that we're saying what we're going to do is we're going to put gender on the columns. So let's do that. And that gives us, and let me zoom in there. So that gives us a nice analysis by class and by passenger type, and it brings out the same things as we saw, the difference between here are women surviving in first and second, and here are our men with progressively weaker odds of surviving as we go from first to second to third class. We might want to do something in this. We don't always have to look at survival analysis. We might just want to say, well, let's have a look at the ages of the people. And we've done here, what we've done is we've done a histogram plot, and we've put a kind of a bin every 5 years, and we've also calculated the mean age, and we've put it as a red dashed line. So let's have a look at that. Again, we can see that there were lots of very young children, infants and toddlers on the boat, but most people, well, like they were starting a new life, maybe were in between 20 and 25. Most people, a lot of people in their 20s, and then progressively decreases with age. So that's an interesting analysis of age. And there's other things we can ask. Money can't buy you happiness, but in this particular case we're doing a box plot and saying, can it buy you survival? What we've got is those who died and those who survived against the fare, and we can say if you paid a higher fare, you're slightly more likely to survive. And let's just have a look at this one, because it's exactly the same as the second power view plot I showed you, but we're just doing it in R. We're looking at women only, and we're looking at this interesting thing that women in third class, the more they paid for their ticket, the less likely they were to survive. And that's so. But and we've done it there in R. Right, so far what we've done is we've done exactly the same in R, exactly the same objective in R as we have done in Excel Power Query Power View. But we can go, this is a quick digression, we can go a bit further with R. So far we've been analyzing the data, and we've been working out what variables contribute to survival or otherwise. But why don't we build a decision model in R to do that for us? And so we're quickly going to do this. This is a bit of a digression from exploratory data analysis, but it's I just want to show the advantages of using R to do that. Before we do that, though, our decision tree models are not very happy with missing data, so I'm just going to run these couple of things. Basically what we're saying here is if we don't know the age, we're going to substitute the mean age. If we don't know the age, we're going to substitute the mean age. And we talked about those two passengers. We didn't know where they embarked. What we're saying is if we don't know where they embarked, then we assume they embarked in Southampton. You may have different ways of doing that. That's just my view on it, and obviously we could change it. But now we've got data that's good enough. First of all, what we're going to do is going to run these, and what we need to do is we need to split our 891 people into a training set and a test data set. The training set we're going to train our model on. So what we've done there is we created a new row with a random variable between uniformly distributed between 0 and 1. We created 891 values of that, and we added it to our data frame. So if I look at my data frame now, you'll see what we did. We created this value called temp_val here, and then we simply said we split it into two sets. 70% of the data obviously is on average is below 0.7, and that becomes our training data set, 622 there, 269 test data set. Add those together, you get 891, so we split our data. Now let's build our model. And it's very simple to build our model. And here we're saying we're going to create a model, and what we're going to do, we're going to try and predict survival, and what we're going to predict it, and I've just chosen these variables. Again, we could try choosing different variables, but these are the variables I said, let's base survival on passenger class, gender, age, family size. In this case, I've used the fare or the fare band and where they embarked. I said, use the training data, and this is a class, so I want, do it basically, it's a binary thing, you either survived or you didn't. So I've created that decision tree. Let's have a quick look at that decision tree. And if I zoom in there, this is the decision tree's view on it, and I'll take a few seconds to explain it. And basically it's saying that if I know nothing about you and then I'd vote that a person died because 62% of people did, whereas the first most important question is whether you're a man or a woman. If you're a man, well, basically it's curtains for you because 81% did. If you're a woman, it's a bit more interesting. We then, on the whole, you survive, but then we have a look about what class you were in, what age you are, what fare you paid, and then we come and then we draw a different conclusion. So that's R's way of doing it. Now, the question is, has R done a good job? And we'll do that. So what we'll do is we'll apply that model to our test data. And then what we'll do is let's just apply that, and then apply that. And then what we'll do is we'll do very quickly, because I'm running out of time a bit, we'll do some analysis of it. So what we're doing is we're doing some counts. True positives, or if I go to the data, or when, let's have a look at our test data. So we've got our test data, and lovely. And we've added these columns. We've predicted the survival. We've actually got the actual survival. So here's our row where we've got it right, somebody's died, and we've said that they've died. Here in this third row here, we've got it wrong because we predicted that they died and they survived. So it's not a perfect model, but how good is it? And we can count our true positives, where we said they survived and they actually did, and our true negatives, where we said they died and they did. And we can come and say, what's our accuracy? Well, that's our when we got it wrong over all the observations. And if we have a look at our accuracy, we've got a value of 0.80, which is 80%. So we've got an accuracy which is better than better than just having a random guess, which would be 62%. So we know our model works, and it works reasonably well, and we've managed to do some predictions there. But as I say, that's just a digression. So what we've done it the same in R as we've done, and now I want to show you another demo, which is, let me just go to my current slide. We've done R, and I want to show you the same thing in Azure Machine Learning. So let me quickly do that. So what I've got as in machine learning is in the cloud, and it's a very different style of building a model. We have lots of wonderful modules on the left-hand side, and we choose a particular module. For example, if I show you all the different models there are, how many different classification models, and then we would just take it and drag it into our middle area and then connect up the various modules. And on the right hand side, where we will, when we click on a particular module, we will be able to configure it. So let's start. So if I go back and show you the big picture here, we've got about 8 different modules which are doing exactly the same thing. and I've connected them all together. So let's zoom in and have a look at the first module. So the first thing is we're just bringing in data, and I brought in our data set, our Kaggle data set. And one of the nice things you can do here is you can just right-click on the module and visualize the data. And it gives a very nice visualization of the data. It shows the data set, and for each data set, it shows a kind of tiny little micro chart. And so we can have a look at our age, and it tells us exactly the same thing as we saw with our histogram with R. So, and for example, if I click on age, it gives the summary statistics. As we said, you know, here's our baby, here's our 80-year-old man, and it gives us the same summary statistics. And it tells us we've got missing values. And it also gives us, again, this little chart. And we can also compare it, say, oh, I want to have a look at age against, for example, let's do it against passenger class. Oops, that's maybe not the best thing to do it against. Let's do it against, embarkation point. And then we get a nice box and whisker chart saying, okay, it seems like the oldest people got on in Sherbrooke and so on. So it gives it all already, without doing anything, it gives us a very nice visualizations of the data. So that's our data as it came in, as it came in. And what I need to do now is I want to do the same operations. So we're going to have a quick look at some of these. I'll show you. So the first one is a project columns, and what I'm doing here is I'm just saying I want to, from that data set, I want to remove some columns. I start with all columns. I'm going to remove some columns, passenger ID, ticket, cabin. Why am I removing them? Because I don't think that they've got any predictive value if I'm going to do a model later on. Then I can do things like I can rename columns, which I've done there, and then I can also, if I'm saying, well, I did these particular columns that were basically they come in as a number, but they're not really numerical columns. As I say, P class is not, it's more passenger class. It's first, second, and third. There's no kind of odd kind of numeric kind of. They're just three values, three categories like low, medium, high. That's what I want them to do. So I'm changing each of those to a category. Okay, and then the next thing I'm going to do is I'm going to basically now, one of the nice things that we can do here is we have this lovely get out of jail free card, which is our data, and we can have a module which is called execute R module. Now, in the likely case that there's so many different modules that you can use, but if there was one that didn't, you can simply write a piece of R code to do it. And here I have. You could certainly do these things but I've written a piece of R code just to show it. And the R code you've seen before is exactly as before. Here's our calculating our survival, our passenger class, and so on. But what's interesting is this thing says bring it in from the top connector and put the data into this data frame df train. And at the very bottom, what we do is we take the revised data frame and we pipe it through the bottom connector. And at the same time as well, if we want to do any graphics, we can do some graphics as our very simplest first plot. So let me just put that back. And so what we can do is if I have a look, again, if I have a look at the exit, if I visualize that, as a result of that, we'll see our data. Let's go to it, and here are our new columns that we've created using the R script. And what we can also do, if we wanted, we can with this second connector, we can visualize that, and that gives us our R chart from the ggplot. So we can incorporate those as we want. Next, we can project the columns, and what I'm doing there is, let me just move that up a bit, is we're excluding, we now know we no longer need those columns. We've got better versions of those columns. We can get rid of them. And lastly, what we can do is we can clean the data. As we mentioned, the age has got some missing data, and what I'm saying is I'm going to take any missing data. I'm using the clean missing data module and I'm going to replace it with the mean, though there's lots of other good ways of replacing it, medium mode and so on, or we could even kind of remove the entire row. So, and then once I've got that data and I've cleaned it, then I'm cleaning. The last thing I'm doing is I'm cleaning it another way. I'm substituting a value. If I have a missing value, then I'm simply substituting S for Southampton in the case. So what we've done here is, again, we've done that, and at the end of it, we can visualize or export that clean data. I'll just visualize it for now. And we can visualize that data, and there it is, including all our new columns, which have been cleaned and added to it. So that's the third way. Azure ML, when we think of doing Azure ML, we obviously think of building kind of predictive models, or obviously doing machine learning or doing advanced data analytics. But what I wanted to show here was you can also use Azure machine learning very easily and very quickly, and it's very helpful when we're just looking at doing our initial exploration of the data. Great. Okay, so let's close that and let's go back to our current slide. So I've showed Azure Machine Learning, and what I wanted to do is I've shown you, I started with a quote from Juki, I'll finish with a quote, and for me this quote encapsulates exactly why we do exploratory data analysis, because it helps us start at the beginning, get things right, we get onto the right road, we get asked the right questions, and rather than asking the wrong questions. And that's why I think exploratory data analysis EDA is important, and I think with these free tools, we've got free tools that make it very easy to do and fun as well. And I hope, I've shown you these free tools. You might want, whichever one you want to use, one of them or all of them, that's your preference. It comes down to that. Lastly, a few references if you want to take this further. I did a course in R at the Coursera, a massively online course. There's kind of a whole suite of courses, including a programming R course. It takes about 4 weeks, about 10 hours a week. It was a really good course, and they run it regularly. I'd recommend that. Fantastic demos, Azure, of machine learning and all this sort of stuff at Azure, at the Azure Machine Learning website. As I say, I'll put up the code at zomlex.co.uk, and just below are kind of the books that I've most enjoyed kind of reading or in relation to this. If you're interested more about Power Query, then there's a Power BI book from Chris Webb. This is the kind of most practical book on R, practical data science with R. I think it's good, and a very good kind of tutorial on Azure machine learning. For more general stuff, these 3 books are on the left. I think are really well written. And with that, I'll say thank you very much. I know I'm coming up to 6 minutes to the hour. I hope you've enjoyed it. Thank you for your listening to me.
Okay, Mark, we got some questions.
Sure, go ahead.
All right, the first one is, will the data being provided today be available to make this, to try to rework what you did?
Absolutely, absolutely. So this is a public data set. It's from a website called Kaggle that do competitions, and this is one of their tutorial data sets. What I'll do is I'll make that available, so with the code, so you can take the code, take the data sets, and actually step by step go through the R code or and the Excel code. I'll make everything available so you can step through each of those demos just as I have done today.
Can you put that slide back up with the link to the site? Is it the?
Yes, so it's http://zomlex.co.uk.
Okay. All right, so the next one is, if I'm an analyst proficient in Excel and Power BI, but have no statistic or computer science background, would you recommend learning R?
I think I'd recommend doing a basic course on statistics first, because if you want to learn statistics, and R is a very good way of a practical introduction to statistics. Yes, I mean you could R is a good way of doing it. I might actually. Yes, because even when you go and learn Azure Machine Learning, I mean, Azure Machine Learning is very wonderful because it gives you all these wonderful things like decision trees and all sorts of wonderful algorithms. But it's useful learning a bit about how they work under the covers. And for that, I'd recommend the first two books that I've got here. Data Science and Business explains a lot of the algorithms. And Data Smart might be the more interesting one for the person asked this question, because he said that he's an Excel person. Now, DataSmart shows you everything from a decision tree to a clustering algorithm, but it does it first. It does it first and it goes an Excel tutorial example, and you can follow along and you can do it in Excel. And because you know Excel, you do it in Excel, you understand it. And then later on in the book, it shows you doing it a lot more simpler in R. So you can understand, and that's how I learned. Oh yeah, I can understand Excel. I can understand what these things are doing. They're not magic. I can understand the algorithm. That's exactly how this clustering algorithm works. But it's a pain to write it in Excel. It gets very verbose very quickly. And here I am doing exactly the same thing in R later on. And so, and that's a very good stepping stone, I'd say, that particular book, for a kind of Excel guru who wants to get more into this.
Okay. The next one is, in the example you provided things to look for. Wonder if you do not know, i.e. you have all the data but you have no idea what to look for. Could Azure Machine Learning provide potential correlation to people's death, i.e. something, gender, etc.?
Yes, I mean, I think it comes back to what the kind of quote about EDA being about kind of attitude and flexibility, and for me, it's looking at the data even before we do things and asking questions. Where had this data come from? You know, for example, why with this data set, why have I only got 900 of the 2,200 passengers? Why are some ages missing? Why are some cabins missing? I'm surely you must know the cabins, especially for first and second class people. You know, those questions, and typically in you know in the environment I work in, there's always somebody who's provided that data. My data, as I said, is kind of financial data like trades. I can go to the people who who running the source system and saying, this is interesting. You said X, but this data suggests that Y. So why is it? So for me, a large part of the explorative data analysis is actually talking to the people and the users. What do you want out of this data, and analyzing data, and then using that analysis to frame really good questions that help you and the person that provided the data gain some insight into the data and understand better what you want out of the data.
Okay, we got probably time for maybe two more. Is
Sure.
machine learning only on Azure?
No, I mean, obviously machine learning, there's many toolkits to do machine learning. I really recommend Azure because I think it's a great place to start. The tutorials are absolutely fantastic. They take you through step by step, and so the amount
I
of
guess
training you can go.
Microsoft-wise, is that the only place ML is available?
Microsoft, oh, I see. So Microsoft-wise, no, I think that's what would, for example, an analysis service had the Excel data mining add-in, and so you can use Excel data mining with analysis services in data mining mode. Those are the two ways I can think of Microsoft ways of doing it. But of course, there's Python as well as and other things as toolkits there, and there's open source approaches.
Okay, and the last one, I think is just a comment. You may have missed one tool, SAS Enterprise Guide. What is your view on EDA?
Right,
Not sure
yes.
what that is.
So there are lots of really good tools out there, and I've just chosen free. So, for example, there's Rapid Miner and there's Nime and there's Weka. So there's lots of, this is, you know, very fast moving, and there's lots of really good tools out there. What I wanted to do was free the very different ways of approaching the problem, and I hope I've done that.
Okay, well, we're out of time. Thank you, Mark,
Thank
again
you.
for doing the session. Thanks to everybody who attended, and please go to his link that you see on the screen with further information. And that's the end of this session.